Okay, let's talk about finding the GCF and factoring the GCF out of an expression. So we'll start with the basics, just finding the GCF of two numbers. So one method that you can take is taking the first number, like in this case it's 50, and making a table of all of the factors. What I like to do is start with 1 and count up. So 1 times 50, 2 times 25, 3 is not a factor, 4 is not, 5 is, 5 times 10, 6, 7, 8, 9 are not. 10 is a factor, but we've already written that down, which means that we've written all the factors. We could do the same thing for 75. 1 times 75, 2 is not a factor. 3 times 25, 4 is not a factor. 5 times 15, 6, 7, 8, 9, 10, 11, 12, 13, and 14 are not factors, but 15 is, so we've made our full loop. So if I'm looking for what factors do they have in common, well, they each have a 1, they each have 5, and they each have 25. But we're looking for the GCF. This is the greatest common factor, which is in this case 25. So 25 is the largest common factor. Another way that you can do this is maybe only make the table for one of your values. I usually take the smallest one because that's going to be the smallest table of values, typically. So 18, what are the factors of 18? Those would be 1 and 18, 2 and 9, 3 and 6, 4 and 5 are not factors. So then you can go through and starting with the greatest factor, ask if this factor, for instance here, 18, is a factor of 24 and 36, which it is not. Then go to 9. Is 9 a factor of 24 and 36? Well, it is of 36, but it's not of 24. So this can't be the greatest common factor. How about 6? 6 is a factor of 24 and 36, which means 6 is the greatest common factor. But you're not just going to have to find the greatest common factor of expressions that have numbers. There's also going to be variables. So if I ask you for the factors of x squared, I'm saying what times what is x squared? We know that that's x times x. For x cubed y to the fourth, that's x times x times x times y times y times y times y. So the greatest common factor comes from figuring out what these two expressions have in common and multiplying them together. So they have an x in common, so that's going to be part of the GCF. They have another x in common, so that's going to be part of the GCF. And there's nothing else that they have in common. So x times x is the GCF, or in other words, x squared. So x squared is the GCF of x squared and x cubed y to the fourth. Another quick way to do this is to consider something like if you have x to the fifth y cubed, and maybe it's x squared y to the seventh. Well, you could multiply all of these out and expand them and say 1, 2, 3, 4, 5 x's times 1, 2, 3 y's, and then 2 x's times 1, 2, 3, 4, 5, 6, 7 y's. And you'll notice that what they have in common is if you have an x here and an x here, another x and another x, they have x squared in common. And then out of the y's, they have one y, a second y, and a third y. They have y cubed in common. So what this turns out to be for your GCF, you'll notice that the exponent here, x squared, of your two options, x to the fifth and x squared, it's the smaller of the two exponents. And then y cubed, well, of your two powers of y cubed and y to the seventh, it's the smaller one. So that's how you can quickly find your GCF. So let's talk about if you have something like 3a and 3b. So if you have 3a and 3b separately, I'd want to ask you what's the GCF? Well, they have a 3 here and a 3 here. So the GCF is 3 because this one has an A, this one has a B, but they don't have both. So this one has an A, but this one doesn't have an A. This one has a B, this one doesn't have a B. So 3 is the GCF. So what if I now take the 3a and 3b and write it like this, 3a plus 3b? So 3a plus 3b is now a binomial that we're going to factor. And the way that we do that is we take that 3a plus 3b and we rewrite it with the GCF in front of the parentheses. So the 3 is going to go in front of a set of parentheses. And this is kind of like undoing the distributive property. So we need to figure out what goes inside the parentheses so that when you distribute the 3, you get back to 3a plus 3b. So 3 times what is 3a? We know that's a. And 3 times what is 3b? That's going to be plus b. So 3 times the quantity a plus b. This is the factored form. This is your answer if I were to ask you to factor 3a plus 3b. Factoring just means write as a product. So we have a product 3 times the quantity a plus b. So we're going to practice kind of both. I know I went a little bit out of order here. Let's just go back and practice a couple times with just finding the GCF, and then we'll practice with what to do. So I've just given you a couple of expressions, 16x and 4x squared. If we want the GCF, look at the numbers first. So 16 and 4. The GCF of 16 and 4 is 4. And then look at the variables. This has an x, this has an x squared. The smallest variable there is x to the first, so x is the only thing that they have in common. Now, if I had written this as 16x plus 4x squared as an expression, and I wanted to factor it, then this GCF would sit on the outside of a set of parentheses, and then we'd have to figure out what's still on the inside. So 4x times what is 16x? That would be 4. And 4x times what is 4x squared? That would be x, or 1x. You could have the 1 there as well. So, but right now we're just looking for what's the GCF. So could you find the GCF of both of these? Maybe try it on your own and then unpause the video. 10d cubed h and 50dh squared. Well, 10 and 50, the GCF of those is 10. D cubed and d to the first means that they only have a d in common. And then h and h squared means that they only have an h in common. So if we were to factor, if this had been rewritten as an actual polynomial and you had something like this where there was a plus sign in the middle, you would put the 10dh on the outside, and then you would have to figure out what's on the inside to get back to this. So 10dh times what will give you 10d cubed h? You're just missing that d squared. 10dh times what is 50dh squared? That would be a positive 5, and then you're just missing another h. Let's do one more. Negative 2x to the 7th y to the 5th and 5xy cubed. So the GCF here, I can see that negative 2 and 5, they only have 1 in common. So you can write the 1 here, but it's not necessary as part of the GCF, because if you write 1y or y, these are the same things. So let's look at the variables. X to the 7th and x means x will be part of the GCF. Y to the 5th and y cubed means y cubed will be part of the GCF. So let's actually start factoring. So I have a lot of examples here that you can go through. We'll do just some of them. We won't do all of them. Looking at number 14, xy minus xz, I can see that the GCF of xy and negative xz is x. So x is going to sit outside the parentheses. The number of terms that you start with should be equal to the number of terms inside the parentheses. So since you're starting with a binomial, you'll have a binomial inside the parentheses. X times what is xy? That's going to be y. X times what is negative xz? That's going to be minus z. You should get in the habit of checking your work by actually multiplying it back together and doing the distributive property. X times y is xy, x times negative z is minus xz. That gets you back to the original problem. You don't necessarily need to write that check. This is your actual answer, but doing that check, at least in your head, is a good idea. 12xy plus 6y. Again, think about what's your GCF first. Of 12 and 6 would be 6. Here you have an x, but you don't have an x in this term. So that means that x is not part of the GCF, but they each have a y to the first. So y is going to be part of your GCF. In the parentheses, you'll have 2 terms since that's how many you started with. 6y times what is 12xy? That would be 2x. 6y times what is 6y? That's going to be a positive 1. I'll do 2 more. Let's jump down here. We have 3 terms here. So 6a cubed minus 12a squared plus 14. So first, 6, 12, and 14. Think about, again, if you had to go through the factors of 6, they're 1 and 6 and 2 and 3. So of those, 1, 2, 3, and 6, what are factors of both 12 and 14, and what's the largest? So of 1 and 6 and 2 and 3, 6 is a factor of 12, but not a 14. So 6 isn't going to work. 3 is a factor of 12, but not a 14. So that's not going to work. 2 is a factor of all. So 2 is going to be part of our GCF. A cubed, A squared, and A, that means out of all 3 of these, the largest exponent is a 1. So A is going to be part of your GCF. And then we should have 3 terms inside. So 2a times what is 6a cubed? That's going to be 3a squared. 2a times what is negative 12a squared? That's going to be minus 6a. And 2a times what is 14a? That's going to be plus 7. Let's go. We'll do the challenge for our last one. So 4x to the 5th y squared minus 16x to the 4th y cubed plus 8x cubed y to the 4th. Of 4, 16, and 8, 4 will be part of our GCF. Of x to the 5th, x to the 4th, and x cubed is the smallest, and x is part of every term, so it's going to be part of the GCF. Y is also part of every term. The smallest exponent is squared, so y squared. In the parentheses, we will have 3 terms. 4x cubed y squared times what is 4x to the 5th y squared? We just need to multiply by x squared. And then it's going to be minus 4 times we need an x and we need a y. And then plus 2 times we have all of the x's. It looks like that needs to be y squared. There's one last thing that we need to talk about. If I tried to factor 4x plus 9y by finding the GCF, 4 and 9, the only thing they have in common is 1. And then there's x's here, but not here. There's y's here and not here. So x and y both aren't part of the GCF. So in this case, if you find out that your GCF is just 1 or even negative 1, think about what that would look like. If you factored out a 1, inside you would still have the same thing, 4x plus 9y. So that's not really helping us. So in this situation, we're not going to write it like that. If your only factor that they have in common is 1, that means that you're not going to be able to factor it. You're actually going to write the word prime. And we have prime numbers, right? Like 3 is prime because its only factors are 1 and itself. Well, the only factors of 4x plus 9y is 1 times itself. So that's why we're calling it prime. So if an expression cannot be factored, we're going to call it prime.